Hi and Assalamualaikum everyone. Now we are going to present about application of first order differential equation, which is Newton's law of cooling or warming. Before we are going to our main topic, let me introduce my group member. First, we have Siti Nuraisha binti Muhammad Yazid with student number 2023881034. Secondly, we have Nur Shazlana Akila binti Abdul Rashid with student number 2023684214. And lastly, my name is Nur Fatihah Shuhada binti Saufi and my student number 2023805832.
Introduction. The Newton's law of heating and cooling states that the rate of change of the temperature of an object is proportional to the difference between its own temperature and the temperature of its surroundings. The principle is commonly used to model real-life heating and cooling processes, such as food being heated in an oven. In this assignment, we apply Newton's law to model the temperature of change of a roast placed in a 180 Celsius oven and determine its temperature over time. Problem statement. Question A. The question is, a roast is going to be put into a 180 Celsius oven. Create a differential equation modeling for this situation. As we know, the general formula for Newton's law of heating and cooling is dT over dt equal to K multiplied by T minus Tm, which are Tt is the temperature of the object at time T, Tm is temperature of the surrounding object, dt over dt is the rate of change of the temperature, T minus Tm is the difference between the object temperature and its surrounding temperature, and lastly K. K is the constant of proportionally. And then we just put the value into the formula, and the answer we will get is dt over dt equal to K multiplied by T minus 180.
This slide explains question B, where we apply Newton's law of heating to model how the temperature of a roast changes over time. First, let's look at the information given in the question. The roast starts with an initial temperature of 25 degrees Celsius. After 20 minutes, its temperature increases to 100 degrees Celsius. We are also told that the surrounding temperature remains constant at 180 degrees Celsius. These values are important because they will be used to find the constants in our equation. From part A, we already know that Newton's law of heating can be written as the differential equation dt over dt equals to Kt minus 180. This equation tells us that the rate at which the temperature changes depends on the difference between the temperature of the roast and the surrounding temperature. Next, to solve this differential equation, we separate the variables. This allows us to integrate both sides of the equation. After integration, we obtain ln T minus 180 equals to Kt plus C, where C is the constant of integration. We then rewrite this equation in exponential form to make it easier to work with. This gives us the general solution. T equals to 180 plus AE power of KT, where A is a constant that we will determine using the given condition. Now, we apply the first condition. At time T equals to 0, the temperature of the roast is 25 degrees Celsius. Substituting these values into the equation allows us to find the value of A. After simplifying, we get A equals to minus 155. Substituting this value back into the equation, the temperature model becomes T equals to 180 minus 155 E power of KT. Next, we use the second condition. When the time is 20 minutes, the temperature of the roast is 100 degrees Celsius. By substituting these values into the equation, we can solve the constant K. After rearranging the equation and taking the natural logarithm, we find that K equals to negative 0.033. Finally, we substitute the value of K into the temperature equation. This gives us the final model. T equals to 180 minus 155 E power of negative 0.033 T. This equation represents the temperature of the roast at any time, measured in minutes, and it clearly shows how the roast gradually heats up and approaches the surrounding temperature of 180 degrees Celsius over time.
Next, we go to the question C. The question C is, what will the temperature of the roast after being in the oven for an hour? For the answer, T is equal to 60 minutes. We substitute the value of T into the equation of T is equal to 180 minus 155 times E raised to the power of minus 0.033 T. So, we get the final answer for the temperature of the roast is 158.60 Celsius. For the conclusion, using Newton's law of cooling or warming, the temperature of a roasting plate in a 118 Celsius oven can be modeled by a first-order differential equations, where the rate of temperature change is proportional of the difference between the roast temperature and the surrounding oven temperature. By applying the given initial conditions, the differential equation can be solved to describe the temperature of the roast over time and to predict its temperature after 1 hour in the oven. The results show that the roast heats up rapidly at first and then more slowly as its temperature approaches the oven temperature. Moreover, Newton's law provides a simple yet effective mathematical model for analysis heating and cooling process in various real-world applications, including cooking, engineering, and environmental systems.